Ever wonder what magic happens inside those giant factories to create the batteries that power our world? From your smartphone to the electric car in your garage, it all starts with a fascinating and complex process. Today, we're pulling back the curtain on battery manufacturing. We'll go from raw materials to the finished cell, step by step. So buckle up, because this journey is going to be electric. Let's start at the very beginning. The ingredients. The heart of a modern lithium-ion battery consists of two key components: the cathode and the anode. The cathode is typically made from a lithium metal oxide, like NMC, which stands for nickel, manganese, and cobalt, or LFP, which is lithium iron phosphate. The anode is almost always made of graphite. These materials don't just appear out of thin air. They are mined and then refined into incredibly pure, fine powders. Think of it like baking a cake. You need high-quality flour and sugar. Here, the purity of these powders is absolutely critical for the battery's performance and safety. Once we have our powders, it's time for the mixing phase. This isn't your average kitchen mixer. We're talking about massive, industrial planetary mixers. In separate tanks, the cathode and anode powders are mixed with a solvent and a special binder polymer. This creates a thick, uniform slurry. The consistency is key. It needs to be perfectly smooth, like a dark, metallic paint. Any clumps or imperfections at this stage can create a weak spot in the final battery, so precision is everything. This process is done in a controlled environment to prevent any contamination. Now that we have our slurries, we move on to coating. This is where the battery starts to take physical shape. Huge rolls of metal foil are fed through a coating machine. A thin, perfectly even layer of the cathode slurry is applied to aluminum foil, and the anode slurry is applied to copper foil. Think of it like spreading butter on a very, very long piece of toast. The thickness of this coating is measured in micrometers, thinner than a human hair, and it has to be exact across the entire roll, which can be hundreds of meters long. After coating, the wet slurry-covered foils travel through a long drying oven. This oven evaporates the solvent, leaving behind a dry, solid layer of active material stuck firmly to the foil. The temperature and speed of this drying process are carefully controlled. If it's too fast, the surface can crack. Too slow, and the factory's efficiency drops. Once dried, we have our electrodes, but they're not quite ready yet. The next step is called calendaring. The freshly coated rolls of electrode foil are passed through to massive, heavy steel rollers that press down with immense pressure. This compacts the powdered material, increasing its density and ensuring good electrical contact between the particles. It's like rolling out dough to get it to the perfect thickness and consistency. This step is crucial for maximizing how much energy the battery can store in a given space. After calendaring, the rolls of finished electrode material are ready for the next stage. Now it's time for slitting. The wide rolls of anode and cathode material are precisely cut into narrower strips, or bobbins, a bit like how a paper log is cut into individual toilet paper rolls. The width of these strips depends on the size and type of battery being made. The edges must be perfectly clean, with no burrs or loose particles, as these could cause a short circuit later on. These bobbins are the direct precursors to the battery's internal components. We've made our core components, and now it's time to put them together. This is the cell assembly stage, and it happens in a dry room. This is an incredibly low humidity environment, drier than the world's driest desert. Why? Because the electrolyte we're about to add reacts aggressively with moisture in the air, which would ruin the battery. In this dry room, machines take the anode strip, the cathode strip, and a special separator film and wind them together into a tight spiral, often called a jelly roll. The separator is a microporous plastic film that keeps the anode and cathode from touching, preventing a short circuit while still allowing lithium ions to pass through. Once the jelly roll is wound, it's inserted into its can or casing. This could be a cylindrical can, like an 18,650 cell, or a rectangular pouch. The next critical step is electrolyte filling. A precise amount of liquid electrolyte, which is essentially a lithium salt dissolved in a solvent, is injected into the can. This electrolyte is the medium that allows lithium ions to travel between the cathode and anode. When the battery is charging and discharging, the cell is then sealed to be airtight. But wait, we're not done yet. The battery still needs to be woken up. This is called formation. For the very first time, the cell is slowly and carefully charged. During this initial charge, a crucial layer called the solid electrolyte interface, or SE layer, forms on the surface of the anode. This layer is like a gatekeeper. It stabilizes the battery and protects the anode from degrading, allowing the battery to be charged and discharged thousands of times. This process can take several days and is one of the most time-consuming and expensive parts of manufacturing. After formation, the batteries undergo a final aging and testing process. They are left to rest for a period, sometimes weeks, to allow their voltage to stabilize. Then they go through a battery of test spun intended. They are checked for capacity, internal resistance, voltage, and self-discharge rate. Sophisticated equipment flags any cell that doesn't meet the stringent quality standards. Only the cells that pass every single test make it out of the factory. This rigorous quality control is what ensures the batteries are safe, reliable, and perform as expected. And there you have it. From raw powder to a fully functional, tested battery cell, ready to power our daily lives. It's an incredible symphony of chemistry, engineering, and precision manufacturing. The next time you charge your phone or start your EV, you'll know about the amazing journey that little battery took to get to you. Thank you so much for joining me on this deep dive into battery manufacturing.